Fluid coding and AI. Laguna M.1 is free to try, but Poolside is not pitching it as another chatbot. It is pitching a coding agent model, one that reads repos, uses tools, edits files, runs checks, and earns trust by finishing real work. The useful question is not whether Laguna M.1 sounds impressive in a launch post. The useful question is whether it deserves a slot in your coding agent stack. By the end, you should know what Poolside claims, how developers can try it, where the hardware reality bites, and why one local benchmark result should make you test carefully. Poolside is not entering this market as a hobby chatbot vendor. Its own docs describe a secure full-stack AI platform for software engineering with IDE integration, browser chat, command line workflows, and administrative tooling. The company also leans hard into enterprise deployment, including customer VPC and on-premises options. That enterprise posture matters because Laguna M.1 is built around controlled coding workflows, not just casual prompt and answer sessions. Poolside announced Laguna M.1 alongside Laguna XS.2 on April 28, 2026. M.1 is the larger proprietary model. Poolside says it has 225 billion total parameters, with 23 billion active per token. It is a mixture of experts model, text only, with a 128,000 token context window, and Poolside lists agentic and chat as the supported modes. The most important line in the release notes is not the parameter count. Poolside says users get the most value from Laguna M.1 in Poolside agent workflows. That means repo exploration, file edits, tool use, tests, and iteration. The supported surfaces fit that idea: Poolside Assistant for VS Code and Visual Studio, Poolside Agent CLI, Poolside Chat, and OpenAI compatible API integrations. Poolside's official benchmark claims are strong, but they are still first-party launch claims. The release notes say Laguna M.1 moved SWE-bench verified from 55.6% on Malibu 2.2 to 65.4%. SWE-bench multilingual moves from 31.1 to 57.4. Terminal. Bench 2.0 moves from 16.9 to 32.7. Poolside's deeper dive post also reports 46.9% on SWE-bench Pro. The setup behind those numbers matters. Poolside says its launch benchmarks use the Laud Institute Harbor framework with Poolside's agent harness, a maximum of 500 steps, sandboxed execution, and consistent sampling settings across tested models. That is useful context, but it is not the same thing as broad independent proof. For coding agents, harness quality, tool access, time budget, and evaluation rules can change the result. For individual developers, the easiest path is OpenRouter. OpenRouter lists Poolside/Laguna M.1 free, as released on April 28, 2026, with a 131,072 token context window, up to 8,000 output tokens, tool calling, reasoning support, and $0 token cost fields. Pi's listing points at the same OpenRouter model path through an OpenAI-compatible completions API. Poolside also has its own API and CLI story. The docs show OpenAI-compatible chat completions, optional streaming, and tooler function calling. The CLI has three main paths: interactive terminal sessions, one-shot automated tasks through PoolExec, and ACP-compatible development environment integration. The interesting part is the automation path, because it can emit new line-delimited JSON for scripts and continuous integration workflows. Self-hosting is where the story becomes enterprise scale. Poolside says proprietary models can run inside a customer's environment, keeping code, prompts, and outputs under that customer's control. But the supported FP8 configuration for Laguna M.1 lists 384 GB of minimum GPU memory, 128 CPU cores, and 1 TB of minimum host memory. That is not a normal developer workstation. The local first-party LLMBench run in this workspace gives a more mixed reality check. It tested the OpenRouter model path, Poolside/Laguna M.1 free across 21 coding cases. The total score was 1385 out of 2100, or 65.95%. Only 4 cases passed and 17 failed. Easy cases scored 91%, but medium, hard, and very hard were much less clean. That result does not mean the model is useless. Several failed cases still scored 65 to 80 out of 100, which suggests partial work rather than total collapse. But it also does not support a clean victory lap. This local suite used different tasks, tools, judging, and provider routing than Poolside's official agent benchmarks. The fair takeaway is simple, promising, but verify on your own repos. Laguna M.1 is not the whole launch. Poolside also released Laguna XS.2, a smaller open-weight model with 33 billion total parameters and 3 billion active parameters. Poolside says XS.2 is available under Apache 2.0, and the Hugging Face card points to local ecosystem support including VLLM, Transformers, TensorRT, LLM, and Allama. So the practical split is clear. M.1 for the larger proprietary agent model, XS.2 for local experimentation. If you test Laguna M.1, do not start with trivia. Give it the kind of job Poolside says it was built for: a real repo, a failing test, exact file paths, an error message, commands it is allowed to run, and a definition of done. Then judge the diff, the explanation, and the test result. A coding agent earns trust by leaving the codebase better than it found it. My verdict is that Laguna M.1 is worth testing if you care about agentic coding models, especially through OpenRouter or Poolside's own workflow surfaces. But I would not treat it as a proven winner from launch numbers alone. It is text-only, self-hosting is heavy, free access may not define the long-term deal, and the local benchmark was mixed. Put it in your eval harness, not on a pedestal. If this helped you separate the launch claims from the practical developer reality, like the video and subscribe to Fluid Coding and AI for more grounded coverage of AI models, coding agents, and developer tools.